And so standard form is really important. And I'm going to give you a couple of examples before I actually talk you through it. Now, it's not important that you remember everything that I'm saying to you. It's important that you kind of understand why I'm doing what I'm doing. So, if we look at powers, and I don't know if you've done powers, but I'm going to explain it to you anyway. I'm going to explain it to you right from the start what are powers and how we use them. You're going to do a couple of exercises, and then we're going to have a look at how that relates to chemistry and how that relates to physics. Okay, so first of all, powers. And you hear lots of things in science and you hear lots of things in maths. So what we're going to do is have a look at my first example. So in terms of questions, you might hear the question in maths, which is what is 5 squared? Okay. So to explain this question, I'm going to assume you haven't done any of this. Some of you may know this really well, some of you won't. What this means is I can write this down as 5 to the power of 2, 5 squared, right? There is a reason why we call it 5 squared, but we're not going to have a look at that. We're going to have a look at what this means, right? So 5 squared means, it doesn't mean 5 times 2, it is not 10, right? What it means is 5 times 5. So I've got 2 number 5s, so my answer is 25, okay? Now, the next thing is if I change this number to the number 3, so my power on my indices, so I'm going to use proper language here. So my power on my indices was 3, it will be 5 to the power of 3, or 5 cubed. Now, this would actually mean 5 times 5 times 5, okay? And this will be 125. I don't expect you to do it in your heads like me. I've done this for a million years. I expect you to use a calculator in science and all the time. So we're going to have a look at when and how and why this is important in science. So certain things are really, simple. And you're going to do these exercises just so you get used to it. So 3 times 3, it doesn't mean the answer is 9, because it says write the following using index notation. So 3 times 3 we would write as 3 to the power of 2, or 3 squared. This one, D, I'm going to do D. 9 times 9 times 9 times 9 times 9 times 9. What's that equal to? As index notation is 9 to the power of 1, 2, 3, 4, 5, 6 nines. 9 to the power of 6. Okay. And 6 to the power of 4, you're not working it out. You're just writing it out. 6 times 6 times 6 times 6. And I'm going to need 4 sixes. That's it. All right. Now, after that, what we're going to have a look at is standard form. This is the important part. I'm jumping. If I was teaching maths, I'd take 2 or 3 lessons to get to this point, even if you were year 9, whatever. But we're jumping because this isn't a maths lesson, it's science. So how do I write each of these in standard form? Okay, because we're using standard form in chemistry. We're going to use a little bit of standard form today. So how do I write these as standard form? So what I've got to think about is the number I want is between 1 and less than 10, right? So it's going to be, so whatever number I've got has got to be bigger than 1 and less than 10. So all I think about, as much as I've said that, all I think about is where do I put my decimal point? So 250 actually isn't like that. Okay, so 250 looks like this. So I could write 250 is 250.00 and ad infinitum forever. So that's 250. And what I want to do is bounce. So I want to think, well, where can I put my decimal point? So this number here is less than 10 and bigger than 1. And my answer to that question is right there, 2.5. Okay, so I'm going to take this decimal point here and bounce it to there. And bounce it once, twice. So the way you would write this number in standard form is 2.5 times 10, because that's how you make a decimal point jump. Bounce, bounce, bounce. times 10s, and I made it jump twice. All right. So to understand this slightly deeper, if I actually do this, 2.5 squared means, well, 2.5 times 10 squared means 2.5 times 10 times 10. 10 times 10 is 100. This would mean 2.5 times 100. And this would actually mean 250. All right. So this is standard form. So what I would like to do in the first part of this session, maybe for about 10-15 minutes, is just answer question 1, question 2, and I'm going to go through question 1 so we can use this in science, right? And we can use it in astronomy, and you're going to find out why. Okay, now, before we start this kind of starter, it's a math starter to a science lesson, does anybody have any questions about what we're doing? No? Brilliant, brilliant, brilliant. Let's just